about radios.
Ratios, Leonardo.
Ratios, that's what it says. Today we're talking about ratios of cats with stripies to cats without stripies. I'm a cat without stripies. Okay. Here we have 1 kitty, 2 kitty cats, 3 kitty cats with stripies. And over here we have 1, 2, 3 plus me. That's 4 kitty cats without stripies. Therefore, the ratio of cats with stripies to cats without stripies is 3 to 4.
Leonardo.
What? Get out of the way, weird big cat. Ah! 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 Okay, today's lesson is over.
I apologize for that. Total mayhem. All right, we are going to talk about ratios today, though, not ratios. Okay. Ratio. All right. So we're talking about ratios today, and we're going to do a few new things with ratios this week. We are going to graph them. We'll be using a lot of tables, and we'll be talking about how you can use repeated addition or subtraction to find equivalent ratios, and things of that nature. So today we're starting on page 273 in our workbooks. Okay, so here it says, local radio station WMTH schedules 2 minutes of news for every 20 minutes of music. Complete the ratio shown in the table at the right. Okay, so here's the table at the right. And it starts off with 20 to 2. So then you're just going to continue to fill in the blank spots in this table. And the way you would do that, right, would be, let's see, this is 20. I can see that the one after it is 40. This will be 30. And then this one in between 40 and 60 is going to be 50. The minutes of news, it's 2, 3, so that will be 4, then it's 5, and this will be 6. And really what you can see there is that I'm just adding 10 each time across the top. And across the bottom, I'm just adding 1 across each time. Now let's look at 20 to 2. If 20 to 2 was instead the fraction 20 halves, and you were going to reduce that, what would you say? You would say, well, I can divide them both by 2, and I would end up with 10 over 1, or 10 ones, or 10 wholes. And then if you look at how you're increasing by 10 each time. And here you're increasing by 1 each time. Okay, so we're going to be talking about how you can find equivalent ratios by using repeated addition like that as well. So we've completed that table. What is the ratio of minutes of music to minutes of news? Music, news. So if you reduce it, you get 10 to 1. Or originally they told you 20 to 2. Now, radio station WILM broadcasts 4 minutes of news for every 25 minutes of music. So which radio station broadcasts more news each hour? Well, let's look at the two ratios we have. We've got 20 to 2 and 25 to 4. So what could you do to figure out which broadcasts more? It's kind of like you've got two unlike fractions and you want to compare them. So if you came up with a common denominator, you could do that. So this is 4, this is 2. So if you multiply this by 2, you can make it 4. But remember that if you do that to this term of the ratio, you've got to do the same thing to this term of the ratio. So let's multiply 20 by 2. And if we do that, we get 40 to 4 compared to 25 to 4. So which radio station broadcasts more news each hour? Well, this one broadcasts 4 minutes for every 25 minutes. This one broadcasts 4 minutes for every 40 minutes. So this one broadcasts more news each hour. Now, let's look at number 10. Which station will have to be on the air longer to broadcast 4 minutes of news? What do you think? Look back on the work we've done so far and answer that question. But before you go, let's look at numbers 11 and 12. Reasoning. The ratio table at the right shows the comparison of books to games for sale at Bert's store and at Gloria's store. Complete the ratio tables. Okay, here's Bert's store and Gloria's store, so you can see what the ratios are to begin with, and you're just going to find the equivalent ratios going forward for both of them. And then, which store has the greater ratio of books to games? So that means which one has more books compared to the number of games. All right? So do that one, and then let's look at number 12. The ratio of soy sauce to lime juice in a homemade salad dressing is 7 to 6. Okay? Here's the table for that one. That's homemade. The ratio of soy sauce to lime juice in a store-bought dressing is 11 to 9. Here's the table for that one. Which dressing has the greater ratio of soy sauce to lime juice? Okay, so you're going to complete the tables, extending those ratios, finding the equivalents going forward, and then come back to this question. Which dressing has the greater ratio of soy sauce to lime juice? All right, so do those problems. Pause the video here and start it up again when you're ready to check your answers. Okay. So, Bert's store has more, and here's how I did it. I completed the tables, and then I found 2 ratios that had one term in common. So here's Bert's store for when he has 24 games, he has 16 books. In Gloria's store, when she has 24 games, she only has 15 books. So that means that Bert's store has the greater ratio of books to games, meaning he's got more books to games than in Gloria's store. Okay, now let's look at number 12. For this one, which dressing has the greater ratio of soy sauce to lime juice? The store-bought one does. And I did the same thing. I found when they had one term in common. So at a certain point, they both have 18 for the lime juice. When the homemade salad dressing has 18 in lime juice, it has 21 in soy sauce. In the store-bought one, when it has 18 parts lime juice, it has 22 parts soy juice. Look, it says soy juice right there. That sounds so gross. Sounds so much worse than soy sauce. Anyway, so the store-bought has the greater ratio. Now, I think I also asked you to do this one up here, so let's take a look. Which radio station broadcasts more news each hour? WILM. Which station will have to be on the air longer to broadcast 4 minutes of news? Well, this one only has to be on for 25 minutes, whereas WHTM has to be on for 40 minutes. So WHTM WAMTH has to be on longer to broadcast 4 minutes of news. Okay, let's look at the next page. So here we are, a bunch of similar problems here. One bouquet of flowers has 3 roses for every 5 carnations. Another bouquet has 4 carnations for every 5 daisies. If both bouquets have 20 carnations, which bouquet has more flowers? Here are the 2 tables. Complete them and then answer the question. And remember what we did before. We looked for when both tables had a term that was the same, had the same value. And then we looked at the other term. Okay, so do 13 and let's look at 14. Higher order thinking, Lauren can drive her car 320 miles on 10 gallons of gasoline. Melissa can drive her car 280 miles on 8 gallons of gasoline. So who can drive farther on 40 gallons of gasoline? Okay, same thing. You're going to complete the table, and then at some point in both tables, Lauren's car and Melissa's car will have used 40 gallons. So then look at how many miles they could drive on 40 gallons, and you'll find the answer. Okay, so do those 2, and I think we can talk about this one too. Fran buys socks in packages that contain 9 pairs of white socks for every 3 pairs of blue socks. Mia buys socks in packages with a ratio of 2 blue pairs to 4 white pairs. It always just helps me to write those ratios to the side so I can hold them in my head. So 9 to 3, and then this one is 4 to 2. And you have to read this carefully because they say them in a different order. In this first one, it says 9 pairs of white for every 3 pairs of blue. And in this one, it talks about the number of blue pairs first. So if you're going to compare the ratios, you have to be sure you've got them in the right order. So it should be 9 to 3 and 4 to 2. Now, if the girls each bought 6 pairs of blue socks, how many pairs of white socks would each have bought? So here are your 2 tables, and then you're going to look for that term that you can use to compare till you can answer the question. All right, so go ahead and do all of those problems, and then unpause the video when you're ready to check your answers. Okay, so here is how I completed those tables. For roses over here, 6, 9, 12, 15. For carnations, 10, 15, 20, 25. And here's how I completed carnations and daisies. Then I found when they both had 20, and I found that when roses and carnations had 20 carnations, they had 12 roses. When carnations and daisies had 20, whoops, I circled the wrong one. Ha! Had 20 carnations, they had 25 daisies. So when they both had 20 carnations, which bouquet had more flowers? Well, here, if you add the total flowers together, you get 32. And here, when you add the total flowers together, you get 45. So carnations and daisies has the more flowers total. Okay, and then for this one, Melissa. Melissa can get, let's see, on 40 gallons, Melissa can go 1,400 miles, and Lauren's car can only go 1,280 miles on 40 gallons. Okay? Now, for Fran and Mia and their sock buying, here we go. When Fran has 6 pairs of blue socks, she has 18 pairs of white socks. When Mia has 6 pairs of blue socks, she only has 12 pairs of white socks. So when they've got 6 blue socks, Fran has 18, Mia has 12. And the way I did it was that I completed the tables and then added the number of, white socks to 6 for each of them. Okay? All right. Now take a look at the next page, 275. Okay, look at these happy kids at the beach. And look at this dog who's about to fly out of the book. And then look at this dog just because he's cute. Cool. My future's so bright I gotta wear shades. Okay, that's enough of that nonsense. Okay, for every 4 adults at the beach one afternoon, there were 3 children. How many children were at the beach if there were 8, 12, 16, or 20 adults at the beach? So, what should we do here to solve this, to answer this question? What do you think? That's right. You should complete the table. So let's start out with the original ratio, which is 4 adults to 3 children. And then we're just going to extend that. And here we're looking for the number of children when there's 8, 12, 16, or 20. 8, 12, 16, and 20. So you can see we're counting by 4s because that's what we started with. So we'll do the same thing with the number of children. We'll count by 3s. 3, 6, 9, 12, 15. And now we can answer that question, right? When there were 8 adults, there were 6 kids. When there were 12 adults, there were 9 kids. When there were 16 adults, there were 12 kids. And when there were 20 adults, there were 15 kids. Okay, now here's something new. Now we're going to take these pairs of numbers and turn them into points on a graph. This is really similar to when we solved algebraic equations and used those x and y values for points on a graph. We're going to do the same thing with these. So the points that we're going to plot are 4, 3, 8, 6, 12, 9, 16, 12, and 20, 15. So here we've got our graph, and at the bottom here it's labeled. So the x-axis is going to show the number of adults, and the y-axis is going to show the number of children. So let's look at that first point, 4, 3. So we'll go over to 4 and up to 3. The next point is 8, 6. So we'll go over to 8 and up to 6. The next point is 12 and 9. The next point is 16 and 12. The next point is 20 and 15. Right there. And you can see when you join those points that you've got a straight line. Okay, so now we've graphed them. So let's look on this next question here. There were 25 children and 15 adults at the beach. Okay, so this is a new ratio, but it's in line with this. If we extended this and we said 25 children, we'd have to go out a little bit. It's a different ratio. 25 children and 15 adults. And then Emery said there were 5 children for every 3 adults. Is he correct? So this is a different ratio from up there. 25 to 15, and he's saying 5 children for every 3 adults. Is he right? What do you think? And how could we find out? You're right. If we reduced this like a fraction, we would come up with 5 to 3. And what did I do there? I divided both terms by 5. Okay, so good job, Emery. You are correct. Okay, I think we have one more page today. Do we, or are we done? Oh, yeah, we got one more page. Okay, so let's look at page 276. Explore ratios in tables and graphs. Okay, so Ellen is shopping for supplies at Jake's party store. Make a table to show how much Ellen would spend to buy 3, 6, 9, or 12 balloons. Then plot the pairs of values in a coordinate graph and use the graph to find the cost of 18 balloons. Okay, so here we have the chart. The ratio is 3 balloons to $2. And if we extend that, we find the cost of 6, 9, and 12 balloons. And then here we've graphed those points. We graphed 3, 2, 6, 4, 9, 6, and 12, 8. You can see the graph here. Now, what about the cost of 18 balloons? That's not on our chart. We haven't done that yet. And this is saying you can actually use the graph to find the answer. So we talked about how these lines are straight because the ratio is consistent. So that means that this line will keep going in exactly the same direction. So if we left off, where do we left? We left off here at 12 balloons. But if that line kept going straight, when it hits 18, you can just go straight over and say, oh, $12. Do you see that? Because the ratio is consistent, the line remains going straight in the same direction, and you can track it to find more points. Okay, ready?
Try it.
What are the coordinates of the point that represents the number of balloons you can buy for $6? What are the coordinates? Okay, let's see. The number of balloons you can buy for $6. So let's go to the graph, to the cost side, and find 6, and then go over, and it's exactly between 8 and 10. So that must be $9, or 9 balloons. Convince me. How can you use the graph to find the cost of 15 balloons? What would you do? Look at that graph. You want to know 15. Well, it's between 14 and 16. So if you went right there and what would you get? You'd get 10. Okay, good. That is all we have for today. Good work. Remember, if you have any questions, you can bring them up at the small group meetings, or you can email me or leave me a message in the YouTube video. So thank you. Keep up the good work. 2 weeks, you guys. 2 weeks for me to cram everything I can into your most impressive brains. All right, I will see you later. Bye.